All right. So in this video, let's add these rational expressions up. Now for here, I noticed that it's 10x squared and 15x, and I did find the LCD previously to be 30x squared. Now, what I need to figure out is, let me rewrite this, 3 over 10x squared plus 7 over 15x. Now, just as in the case of numbers, I want the denominators to be the same, and I want them to be exactly 30x squared. So I have to figure out what I need to multiply 10x squared by to get 30x squared. So that would be 3 and a 3 up top here. Similarly, what do I need to multiply 15x by? I have to multiply 15x by 2x. So this is 2x over 2x. And then what does that make it? That makes the numerator of the first term 9, the denominator 30x squared as expected, 14x and 30x squared. When I add them up, 9 plus 14x, they are unlike terms. They are not like terms, so they don't combine, and the denominator stays as 30x squared. All right, so the second one. Now here, the LCD, the highest power for x plus 3 is just x plus 3, and the highest power for x minus 3 is just x minus 3. So the LCD is x minus 3 times x plus 3, which means this becomes x over x minus 3 plus x minus 1 over x plus 3. I multiply the first one by what is missing. What is missing is x plus 3. So x plus 3 over x plus 3. And what is missing on this one, which is x minus 3 and x minus 3. And then when I rewrite, it's exactly what I want it to be. So it's x times x plus 3 plus x minus 1 times x minus 3 over x plus 3, x minus 3, which is the LCD, right? Now FOIL this out on the top to get x squared plus 3x plus x squared minus 4x plus 3, x plus 3, x minus 3, which becomes x squared minus x plus 3 over x plus 3, x minus 3, which is going to be the final form. Now let's look at a more complicated problem. So in this case, you have two denominators and they are not in their factored form, right? So first, we are going to factor the denominators. The first one is x squared plus x minus 6. So I write that as x squared plus 3x minus 2x minus 6. X plus 3 minus 2x plus 3, which becomes x minus 2, x plus 3. And the second one is x squared plus 4x plus 3, which is x squared plus x plus 3x plus 3, which is x times x plus 1 plus 3 times x plus 1, which is x plus 3 times x plus 1. Okay, so this is standard factoring of trinomial by splitting the middle term. Now, to find LCD, what's the highest power of x minus 2? It's just x minus 2. The highest power of x plus 3 is x plus 3, and the highest power of x plus 1 is x plus 1. So x plus 3 covers both the x plus 3's, which means the LCD is x minus 2 times x plus 3 times x plus 1. So now I'm going to rewrite them in their factored form. So it's x minus 1 over, remember this factored as x minus 2 times x plus 3 minus x minus 2 over this factored as x plus 3 times x plus 1. Now what is missing in the LCDs of each is, the first one is missing x plus 1. So I multiply divide by x plus 1. And the second one is missing x minus 2. So I multiply divide by x minus 2, and as a result of that, I can see that my denominators in both are the same, and they are the same as my LCD. So my denominator is x plus 1, x minus 2, x plus 3. And over here, what do I have? X plus 1 times x minus 1. Okay, we'll do that in a separate step. Minus x minus 2 times x minus 2. From there, that is x squared minus 1, difference of square, minus x squared plus 4x minus x squared minus 4x plus 4 over x plus 1, x minus 2, x plus 3, which then becomes x squared minus 1 minus x squared plus 4x minus 4 over x plus 1, x minus 2, x plus 3. X square cancel. So I have a 4x minus 5 over this LCD. Okay, so once I have my LCD, I multiply, divide by what is needed on each fraction. I combine, I FOIL, and after FOILing, I see if there are any cancellations. So for example here, the x squared term cancels, so you do not end up with something which has x squared in the numerator. Okay, I have a couple more examples here. Let's do a simple one right here. Notice that the only difference between these is a product of negative 1. This is actually negative 1 times 5y minus x. Right? So they are essentially the same, they are only separated by a negative. And when that is the case, what you can do is you can simply change the sign of the operation. So if this is a plus, it becomes a minus. If it's a subtraction, it becomes an addition. And this is because of this. You can rewrite it. And now since the denominator is common, we can just straight up combine as 4x minus 16y minus x plus 6y, which becomes 3x minus 10y over x minus 5y. Okay, so that's a quick way of doing it. If you have two terms and they are separated, or there are only differences in the signs. Okay, let's go back to a more complicated example. There are 3 terms here. Now, even though there are 3 terms, the method doesn't change. So you have one factor y minus 5, one factor 3y plus 4, and then you have this term, which right now we don't know what it is, but let's try to factor it. So we need the product to be 3 times negative 20, negative 60. And we need the sum to be negative 11. So let's see, how many ways can I get this? So I can have 1 negative 60, 2 negative 30, 3 negative 20, 4 negative 15. Oh, that looks like the one that's going to work, because if you add these, you get negative 11. So let's go ahead and do that. So 3y squared minus 15y plus 4y minus 20, 3y, y minus 5 plus 4y minus 5, 3y plus 4 and y minus 5, which is exactly these terms. So the LCD is just that, because you already have one copy of all of the things you need. So the LCD is 3y plus 4 and y minus 5, which means you don't have to multiply, divide anything on the first one. So let's rewrite the problem. Y minus 5 plus 4 over 3y plus 4 minus 7y squared plus 24y plus 28 over, we already factored this, so let me write it in the factored form. Now, in order to make the denominators the same, this is missing a 3y plus 4 and a 3y plus 4. I'm going to cramp for space here, but this is missing a y minus 5 and a y minus 5. Once we get that, my denominator is y minus 5 times 3y plus 4, and my numerator, actually I'm going to write that down here. So I have y minus 5 times 3y plus 4. So I have a 3y plus 4 times a 3y plus 2 plus, this looks like I can distribute it right now, 4y minus 20. Now the subtraction distributes, so it's minus 7y squared minus 24y minus 28. FOIL this out, 3y times 3y is 9y squared plus 3y times 2, 6y, 4 times 3y is 12y, 4 times 2 is 8, plus 4y minus 20 minus 7y squared minus 24y minus 28 divided by y minus 5 and 3y plus 4. Now let's collect the like terms. So there's a 9y squared minus 7y squared, that gives me 2y squared. Then I have a 6 plus 12y, that's 18y, plus 4, 22y, minus 24, so negative 2y. Then I have an 8 minus 20, negative 12, minus 28, negative 40. All of this divided by y minus 5, 3y plus 4. Now in the numerator, it's immediately obvious that I can factor out a 2 and a y minus 5 and a 3y plus 4. Let's quickly check. Negative 40, 1, negative 40, 2, negative 20, 4, negative 10, 5, negative 8. So none of these add up to negative 1, so that means it cannot be factored any further, and we can stop here. So that would be an example where you have more than 2, even 3 or 4 of them, but the process doesn't change because you're still finding the LCD, making the denominators common, and then combining the numerators using the easy case, which is when the denominators are same, you can just add or subtract the numerators. Okay, there's going to be one more video in this series where we talk about something called more complicated fractions, or fractions of fractions. But as far as rational expressions, addition, subtraction, multiplication, division goes, this is the end of that for rational expressions. Thank you.